Hello students, we are ready with our new video. In the previous video we have discussed the multiplicity, we have discussed the splitting pattern observed between different compound. In this video we will focus on few more examples of different compound and we'll try to determine their multiplicity. We will try to determine their singlet pattern, triplet pattern, doublet pattern. We will see how different compounds are will give us different type of multiplicity in nature. These are different examples you can see here. These are some different simple example. We can see that it is 1,1 dichloro 2 bromo 2,2 dibromo ethane. How this compound will show the multiplicity? You can see here it is 1 CH, it is 1 CH. So its neighbor is 1, its neighbor is also 1. So it will show you doublet, and this will also show you doublet. In this compound, as you can see here, there is 1 CH and there is 2 CH. So its neighbor is 2 and its neighbor is 1 only. So we will get here triplet, and for this compound we will get doublet. In this case, we will have for this two compounds, two CH are same. We can see here, and this CH3 are all H3 are same. So we can see here, it will show us quartet. These two will show us quartet, and these three will show us triplet. Simple example again here. Neighbor of the CH2 is only 1 CH2, so it will show us triplet. It will show these two are same, as you can see here, so it will also show us triplet. For this compound, for this CH2, it is neighboring, its neighbor are CH2, CH2, 2 CH2. So we can see here 4 neighbor are present here. So in this case you will have quintet or pentate in this case for this compound, for the CH2. So for these two CH2 we will have triplet appearing at the same position. The CH2 and this CH2 triplet will be at the same position, and this CH2 neighbor are 4, so we will have quintet. Again simple compound. For this CH, neighbor is 2 only, so it will show us triplet. Again, these two are same, as you can see here, these two are same, so this will also show us triplet. And these two triplet will appear on the same position at the same delta value. And in this CH2, neighbor are 2, so it will show us triplet again. You can see here, it is symmetrical compound. These CH3 and these CH3 are same, so we can see here, these 6 or we can say these total 12 will show us doublet for this and doublet for this, and we can see here 1, 2, 3, 4, all 4 are in same environment, so all 4 will show us a doublet for 3, 6, 9 and 12. So we will observe doublet for 12 protons. Similarly, these two are same, so we will observe for this compound heptate, for this heptate, and these two heptate will appear on the same position and same delta value. So we will observe a heptate for 2 protons and doublet for 12 protons in this compound. In this simple compound, it is ethyl acetate. We can see here there is no neighbor, so this will show us simple singlet compound, singlet peak. And for this CH2 neighbor is CH3, so it will show us quartet. And for the CH3 neighbor is CH2, it will show us triplet. If we have to consider the value, delta value, then it will be around 2.1, it will be around 3.7, it will be around 1.2. In this case, you can see here, these two CH2, CH3 are same. So, and these 3 H3 are neighboring of, are in close proximity of the CH. So these will show us doublet. These two CH3, CH3. So we will observe doublet for 6 protons, and for this CH neighbor are 6, so we will observe heptate for 1 proton, and again singlet for 3 protons. Value, this will show us slightly higher value because slightly low value because it is primary CH3 and this carbon is attached to oxygen, but it is tertiary in nature, so it will have a slightly higher value than this at protons. We can see here these two CH3 are same, and neighbor is only one CH, so we will observe doublet for 6 protons. So these 6 protons will show us a doublet. CH neighbor are 6, so it will show us haptate, and there is no neighbor, so it will show only singlet. If we consider the value, highest will be of this CH3 because it is attached to the oxygen directly, then to this CH because it is attached to CO around 2.1, then around 1.2 for these CH3. So these are different examples. So we are done with different examples of multiplicity. I'm sure it must be very clear to all of you. So now up to this point we have discussed different examples of multiplicity. Now we're moving towards the second topic. Second topic is, again we are going back to another topic we have already discussed: singlet, doublet, triplet, quartet, quintet and sextet. This triplet nature, this nature of multiplicity you must be finding some confusing, because if I say doublet, so what do I mean by doublet? Do I mean doublet like this, or do I mean doublet like this, or do I mean doublet like this? This is also doublet, this is also doublet, this is also doublet. If I say triplet, then this is also a triplet, this is also a triplet, this is also a triplet. So what I mean? I mean that if I say doublet, so I should be very clear of what do I mean. It means doublet means what is the nature, what is the type of peak we observe in doublet, what is the type of peak we observe in triplet. It means what are their intensity, whether they are 1:3:3, whether they are 3:1:1, whether their intensity is 1:3:1, or whether doublet is 1:1, whether doublet is 1:2, whether doublet is 2:1. So we should be very clear. If we are having a doublet, so what is the intensity of doublet peak? If we are having a triplet, then what is the intensity of triplet peak? If we are having a quintet, then what is the intensity of quintet peak? So in order to define the different peaks, we should also define the intensity. So in order to make this point further clear, we should move back to the point, we should move back to the n+1 rule we have already discussed in our previous class. So I'm again discussing the n+1 rule again to explain this nature of the peak intensity and it will further clear our concept of n+1 rule. Suppose I take a simplest example, CH and CH. Suppose I take this, right? This is, suppose I say it is proton A, it is proton B. Proton A have two neighbor, having one neighbor which is B. If neighbor is B, then I have told you that B is a proton, and proton can adopt two different orientation. One orientation is alpha and second orientation is beta. So suppose I say my neighbor is B and orientations are alpha and orientation is beta. So B proton will generate two type of magnetic field. One will be in alignment of the external magnetic field, and second will be one which will be opposing the external magnetic field. So if I have already told you, suppose magnetic field generation is M. So this A will observe two type of magnetic field. One will be M plus M and one will be M minus M. So proton B will generate two type of environment, capital M plus small m, capital M minus small m. So two different type of magnetic field will be generated, and these two type of magnetic field will generate two type of environment around this proton A, and it means that proton A will be showing us two different type of precision frequency, and it means it will be showing us resonance at two different radio frequency source. So this A will show us two precision frequency, and two precision frequency means two tuning with two radio frequency source, and tuning with radio frequency source means two type of peak will be observed. So A will be split into a doublet because two type of peak will be observed. And what will be their intensity? Intensity will be same because it is generating one environment and it is generating second environment, so intensity will be 1:1. 1:1. Intensity of peak in case of doublet will be 1:1. 1:1, because one type of environment is generated by alpha and the second type of equal intensity environment is generated by beta. So one is alpha, one is beta, two environment, two precision frequency, two tuning with radio frequency source, and two peaks will be observed, and intensity of peak will be not 1:2, not 1:3, not 1:4, it will be 1:1, because in effect of alpha will be in same in magnitude with the effect of beta in magnitude, so it will be 1:1 in intensity ratio. So ratio will be 1:1 in case of doublet. If there is a singlet, there is no, in case of singlet there is no confusion, singlet will be 1. It is just a singlet. But in case of doublet, intensity will be 1:1. Now I am moving toward slightly difficult environment where we are having a neighbor CH with CH2. So in this case, suppose I consider this as B. A is having two environment. It is having two type of proton of B. B is having two protons. One is this and one is this. So what are the possibilities? Possibilities are both may exist in alpha form. Possibilities that both may exist in beta form. Possibilities that it may exist in alpha, it may exist in beta form. Possibilities that it may exist in beta, it may exist in alpha form. These are the total possibility, 4 possibility in which these two proton may exist. These two proton may be alpha alpha, these two proton may be beta beta, these two proton may be alpha beta, these two proton may be beta alpha. So these are the 4 possibilities in which these two proton may exist. So these possibility, as we can see here, alpha alpha and beta beta are the two extreme environment possibilities where both are aligned in, both are in alignments. It is in alignment, the strongest field will be observed. It is in a position, so strongest opposition will be observed, so weakest field will be observed by proton A. If they are in alpha alpha, so 1m, so it will be strong field will be observed by proton CH, because they are in alignment. Both of them are in alignment with the external magnetic field, so they are in alignments. They are in opposition. Two extreme cases, they are in opposition. So in this case, both of them are in opposition mode. So both of them must be opposing the external magnetic field. So magnetic field experienced by proton A will be very less in this case. Magnetic field experienced by proton A by these orientation will be very high when they are alpha and alpha, and magnetic field will be experienced by in these two possibilities will be nullified, because one will show the alignment and one proton will show the opposition, so no effect. So in these two cases, no effect on magnetic field will be observed. So proton A will observe the magnetic field which is applied on magnetic field only. So in case of in these two cases, these two cases will show us the effect which are nullifying each other. Alpha show the enhancement, beta show the opposition. So overall effect will be nullify effect in these two cases. So no effect will be observed. So proton A will observe just M magnetic field, which is the just applied magnetic field will be observed by A. In this case, M plus 2M will be observed when they are having alpha and alpha orientation effect. When they are having beta and beta orientation effect, so M minus 2M magnetic field will be observed when they are existing in a beta and beta form. But when they are existing in an alpha and beta form, effect will be 0, nullify effect, and they will observe just M magnetic field when they exist in a alpha, beta or beta alpha states. So in this case, what are the different types of environment? Types of environment are 3 only. 1, highest magnetic field environment, lowest magnetic field environment, and intermediate magnetic field environment by 2. So what will be different type of peak will be observed? Peaks will be peaks will be observed. One, highest magnetic field environment by alpha alpha, lowest magnetic field environment by beta beta, just M environment by alpha and beta and alpha. So 3 type of peaks will be observed, and the ratio will be 1:2:1. Why I'm saying 1:2:1? Because it is existing, possibility of its existence is 1, possibility of their existence is 2, possibility of its existence is 1. So peaks ratio of peaks will be 1:2:1. 1:2:1. So ratio of triplet. So whenever you write a triplet, you should write triplet in the ratio 1:2:1. So doublet you write as 1:1. Triplet we write 1:2:1. So it should be very clear to all of you that we are moving toward slightly difficult concept. We are moving toward from nature of peaks to their nature of intensity of peaks. So in case of doublet, ratio will be 1:1 ratio, but in case of triplet, ratio will be 1:2:1. You must be understanding why I'm saying 1:2:1, because possibility of its existence is 1, possibility of beta beta existence is 1, possibility of these two combinations are 2. So ratio is 1:2:1. 3 type of environment will be observed in case of triplet. Suppose I say I'm having CS3. Suppose if I'm having CS3, so proton at A, neighbor are 3 proton, 1, 2, and 3. What are the different possibilities? Possibility is that alpha, alpha, alpha. Possibility is that alpha, beta, beta. Possibility is beta, alpha, beta. Possibility is beta, beta, alpha. Right? Then we have alpha, alpha, beta. Then we have alpha, beta, alpha. Then we have beta, alpha, alpha. And then we have beta, beta, and beta. These are the different possibilities in which these 3 protons may exist. Possibility is that all of them may exist in alpha, alpha, and alpha states. Possibility is that all of them may exist in a beta, beta, and beta state. These are 2 extreme cases when they exist in a alpha, alpha, alpha extreme case, beta, beta, beta extreme case. In alpha, 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 all of them are in alignment with the external magnetic field. But in case of beta, all of them are in a position with the external magnetic field. So and other than alpha, 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 and beta, 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 we have alpha, beta, 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 alpha, beta, 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 alpha, 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 beta, alpha, beta, alpha, beta, alpha, alpha. These are the possibility. So if I have to consider what are the chance of occurring? Chance of occurring is 1. Chance of occurring is occurring of this possibility is 1. Alpha, alpha, alpha. They will generate same type of effect. These 3 will generate same type of effect. These 3 will generate same type of effect, and this one will generate same type of effect. I am repeating again here that possibility of the occurrence is that these 2 extreme cases, alpha, 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 1 possibility. These 3 combination will show same type of effect, but they are occurring 3 times. 1, 2, 3. The possibility of occurrence is 3. So in this case also, in this combination also, three combination are possible. This and this three combination are possible, and possibility of their occurrence is 3 times. Again, here in this combination 2 are alpha, 2 are beta. In this combination 2 are alpha. In this combination all are alpha. In this combination all are beta. So possibility of occurrence is 1 is to 3 is to 3 is to 1. So if you have to write any quartet, so we will observe how many type of environment are present here. Environment are 4 types. Environment are 4 types. One caused by alpha alpha alpha. One caused by these 3 combination. One caused by these 3 combination. One caused by beta beta beta. So we have 4 different environment in this case. So we will observe a quartet in this case of when we have 3 neighbor. So when we have 3 neighbor, we will observe quartet, and the intensity of the quartet will be 1 is to 3 is to 3 is to 1. 1 is to 3 is to 3 is to 1. So ratio of the peaks will be 1 is to 3 is to 3 is to 1. So it is, if it is 1 centimeter long, it will be 3 centimeter long, it will be 3 centimeter long, it will be 1 centimeter long. So ratio of the intensity of the peak will be 1 is to 3 is to 3 is to 1. So we are done with CS3, we are done with CS2, we are done with CS2 neighbor also. Suppose if we are having the CH and neighbor are CS2, suppose if I say that. So similarly in this case also we can consider different combination by these 4 proton. If we are having 3 neighbor, 3 here and 2 here, we may consider different combination of here proton also. If we are having 3 neighbor here, so we may consider different combination of these 3 and these 3 also. So by arranging different combination of protons and different combination and means different type of the orientations, we may arrive at different type of peaks. So this triangle is called Pascal triangle. Pascal triangle. According to this Pascal triangle, we can determine the intensity of the peaks. If peaks are singlet, ratio of peaks will be 1. If doublet, ratio will be 1 is to 1. If triplet, ratio will be 1 is to 2 is to 1. If quartet, 1 is to 3 is to 3 is to 1. If quintet, 1 is to 4 is to 6 is to 4 is to 1. If sextet, 1 is to 5 is to 7, 10 is to 10 is to 5 is to 1. So similarly, by just looking at, I have explained you how do we arrive at this different combination, how do we arrive at different ratios of peaks up to 3 proton. So similarly, by taking 4 proton as a neighbor, similarly by taking 5 proton as a neighbor, similarly by taking 6 proton as a neighbor and arranging them in different orientations combinations, we may arrive at different intensities ratio. So whenever you will write singlet, you will write singlet as just 1 peak. Whenever you write doublet, you write doublet as 1 is to 1. You write triplet as 1 is to 2 is to 1. Quartet 1 is to 3 is to 3 is to 1. Quintet 1 is to 4 is to 6 is to 4 is to 1. Sextet 1 is to 5 is to 10 is to 10 is to 5 is to 1. So these are different ratios we should take into consideration whenever we write different type of peaks. So now we are moving toward clarity. We have discussed different type of peaks. We have discussed different type of their multiplicity in nature, where they are singlet, doublet, triplet, and quartet and sextet. And for moving ahead one step again, we have discussed their intensity ratio. If they are doublet, what will be doublet? Doublet will be, if they are doublet, what will be doublet? Doublet will be 1:1. Triplet will be 1:2. Quartet will be 1:3:3:1. So this is the concept which was left in n+1 rule. So now I'm done with n+1 rule. I'm sure it must be clear to all of you. So these two concepts must be, I think these two concepts must be clear to all of you. So we will discuss a new concept in our next video. Thank you.